Hello makers! Imagine that you are building a weather station that needs to operate for months. The built-in Arduino EEPROM memory is only enough for a couple of sentences. What should you do? That's right, use a micro SD card. Today we will take a detailed look at this popular module. This module works via the SPI interface, which stands for Serial Peripheral Interface. It is a fast data transfer protocol. Let's take a look at the pinout. Here we have 6 main contacts. GND is negative, VCC is positive, MISO is data from the card to Arduino, MOSI is data from Arduino to the card, SCK is the clock line, and finally CS or chip select is designed to select the device. This is important if you have several modules that work via the SPI interface. Now here's an important point. SD cards themselves operate strictly at 3.3 volts. If you supply them with 5 volts directly, the card will burn out. But why do we say that this module is for Arduino, which uses 5 volts? Take a look here. There is this component on the board. It is a voltage regulator. It converts the input 5 volts to a safe 3.3 volts to power the card. And this microchip is a logic level converter. It protects the data lines. To find out if you can connect the module to 5 volts, look at the board. If you see a stabilizer, usually a part with 3 legs and a large back, and an additional microchip with many legs, feel free to connect it to 5 volts. If there is only a connector and pins, this module requires exactly 3.3 volts and is not suitable for us. Now let's connect this module to the Arduino Nano. The connection to the Arduino Uno will be the same because they work on the same chips. Why am I emphasizing this? Because the Arduino Mega uses other fixed pins, which I will explain later. The module's VCC goes to 5 volt Arduino. Connect GND to GND on the Arduino. Connect MISO to pin D12. Connect MOSI to pin D11. Connect SCK to pin 13. And finally CS or chip select, we will connect it to the 10th. But you can assign any free digital pin in the code.
In turn, for the Arduino Mega, connect the MISO pin to pin D50, MOSI to pin D51, SCK to pin D52, and chip select, for example, to pin D53.
Let's move on to the code. We don't need to download anything. The SD.h library is already in the standard Arduino IDE set. First, connect the SPI.h and SD.h libraries. Then specify the CS pin, which we have 10. In the setup function, initialize the card. If the card is not found, display an error. Now create the data.txt file and write a line of text to it. After successful writing, we open the same file again, but this time for reading, and output its entire contents byte by byte to the port monitor. Be sure to close the file with the close command after writing and after reading, otherwise the data will not be saved or not be available. Load the sketch, open the port monitor, we see the messages initialization done, and writing to data.txt done. Immediately after that, the code starts reading the file, and we see the content we just wrote right on the console. This confirms that the data has been successfully saved. And now, the moment of truth. We take out the card and insert it into the computer. We open the folder. Here it is, the data.txt file. Inside is our text. It works. As you can see, adding memory to your project is very easy. In the description near the like and subscribe buttons under the video, I will leave the connection diagram, this code example, and the link to the module itself. Thank you for watching and see you in new videos.